External rotor and internal rotor describe mechanical geometry. In an internal rotor motor, the rotating member sits radially inside the stator and usually transfers torque through a shaft. In an external rotor motor, the rotating member surrounds the stator and may carry the impeller directly. Do not translate that geometry into an electrical label. External rotor does not automatically mean EC, permanent magnet, or variable speed, and internal rotor does not automatically mean AC induction, fixed speed, or VFD driven. Record rotor geometry, motor type, supply, drive, and control interface separately. A cutaway must identify the exact stationary stator, rotating member, shaft or outer shell, bearings, impeller connection, and controller location. The rotating outer shell and attached impeller remain moving hazards. Compact integration is not permission to remove a guard. Compare complete fan assemblies at the same declared duty point, airflow, pressure, air density, speed, electrical input, and included accessories. Motor efficiency, nominal watts, or maximum free airflow alone cannot establish wire-to-air performance in the intended system. Installation can change the result. Guards, screens, filters, coils, elbows, cabinets, blocked inlets, outlet transitions, and recirculation add system effects. Select from a complete fan curve and stable operating range, then verify the installed arrangement. An external rotor can reduce axial package depth in some integrated designs, while an internal rotor can support shafted, direct drive, or transmitted arrangements. Compare the complete envelope including inlet cone, supports, controller, connectors, guard, cooling clearance, lifting, and service access. Rotor radius can influence torque production and inertia, but mass, electromagnetic loading, pole count, control strategy, speed, and the impeller decide the outcome. Higher inertia may smooth a short disturbance yet increase acceleration time and stored energy. Require actual curves and combine rotor plus impeller data. Cooling and temperature are product specific. Check winding, magnet, bearing, and electronics temperature under the declared airflow, speed, ambient, altitude, mounting, contamination, and duty. Integrated electronics also bring grounding, shielding, EMC, harmonics, leakage current, residual voltage, and restart requirements. Analog, PWM, serial, and building control interfaces are not interchangeable. Verify minimum speed, isolation, scaling, fault outputs, sensor supply, ramping, stall protection, reverse behavior, communication loss, and automatic restart. A zero-speed command is not hazardous energy isolation. Balance, vibration, bearing life, and sound belong to the complete rotating and installed system. Review impeller mass properties, balance planes, mounting stiffness, resonance, loads, lubrication, temperature, speed, contamination, blade passing tones, switching tones, and comparable sound power evidence. An IP code does not automatically prove corrosion, condensation, washdown, chemical, outdoor, hazardous location, or smoke control suitability. Match the motor, electronics, connector, cable entry, and final fan assembly to the exact environment and certification scope. Never energize an exposed or unrestrained fan, probe live terminals, overspeed it, or service it without isolation and stored energy control. Release a matched duty buying passport, topology, electromagnetic type, supply and drive, control map, complete fan curves, duty point, power boundary, thermal limits, system effects, vibration and sound evidence, environment ratings, guards, restart behavior, service plan, spares, warranty, and exact certifications. Choose the assembly, not a universal topology winner.